This lesson is a continuation of grade 8 review, specifically on integers. What is an integer? An integer is any whole number. Integers include positive numbers, negative numbers, as well as 0. They cannot be decimals or a fraction. Write the following integers from lowest to highest. The lowest integer here is -7, then -5, then -1, then 0, 3, 5, 10. Adding integers. An example with a number line. 5 plus -7. I'm going to begin with marking integer 5, which is right here on the number line. Now we're adding -7 to it. So that -7 is going to tell us that we need to move to the left 7 units. So we're going to move to the left 7 units. 1, 2, 3, 4, 5, 6, 7. We land at -2. So 5 plus -7 is -2. Another example, -3 plus -4. -3 plus -4. So that -4 is going to tell us that we're going to move to the left 4 units. 1, 2, 3, 4. -7. In grade 9, we move away from using a number line. So a lot of this simplification of integers occurs now in our heads. You can still imagine the number line in your head, but I'm going to encourage you to sort of move away from the number line and algebraically simplify these integers. There should only be one sign in front of each integer. So when you see double signs, like up here, we had double signs. We had a positive and a negative beside each other. Here we had a positive and a negative beside each other. When we see double signs, we need to automatically simplify those double signs to 1. So when you see 2 positive signs, they will simplify to a positive. Same thing with 2 negatives. When you see 2 negative signs, they will simplify to a positive. When you see a positive or a negative beside each other, they will simplify to 1 negative sign. If there is not a sign in front of the first integer of the expression, we assume that there's an invisible positive sign in front of it. So right now in front of 5, we don't see a positive or negative sign. So we assume that there is a positive sign in front of that 5, but we just don't have to write it. When we begin an expression, a numerical or an algebraic expression, when we begin that expression with a positive integer, we're not going to write a positive sign in front of it. It's just going to look like this 5 does right here, 5. We understand that that 5 is positive. So that happens for the first integer of the expression. In number 4, we see that 3 is actually not positive, and it's indicated with that negative sign in front of it. This integer, 1, is positive, and it's indicated with a positive sign in front of it. We have to write that positive sign in front of the 1 because it happens in the middle or at the end of an expression. So only when a positive integer occurs at the very beginning do we not have to write a positive sign in front of it. Let's look at number 3. We need to simplify this expression so that each integer only has one sign in front of it. Okay, so the 5, because it's positive and because it occurs first, we don't actually have to give it a sign. We understand that it's positive. There's an invisible positive there. But now we need to simplify these to negatives. Okay, so let's go back to up here. So 2 negatives will equal to a positive. I'm going to rewrite subtract -2 to just +2. Okay, so now each integer only has one sign. And now that's easy for us to add. 5 plus 2 is equal to 7. We just simplified this expression without using a number line. Let's try again with question 4. So -3 is fine because it has one sign in front of the 3. Now in front of the 1, there's 2 signs. There's a negative and a positive. When you see a negative and a positive beside each other, we're going to simplify that to 1 negative. And then -3 subtract 1 is -4. Something else that we are introduced to in grade 9 is that negative signs in subtraction, as well as positive signs in addition, are interchangeable. They mean the same thing. Let's look at number 4. This says -3 subtract +1. We can also read it as -3 negative +1. We can also read it as -3 negative +1. The negative and positive signs mean the same thing as subtraction and addition. Another example, we just simplified 5 subtract -2 to 5 plus 2. We can also read this as 5 positive 2. Moving on to multiplying and dividing integers. The rule is, look at the signs of the integers. When the signs are the same, the answer will always be positive. When the signs are different, the answer will always be negative. The invisible -1. A negative sign in front of the brackets is an invisible -1. In front of the brackets, we have a negative. We understand that this actually means -1 times 3. Okay, and also over here, this is a -6, which we understand means -1 times -6. Solve. -2 times 7. So this 7 has an invisible positive sign in front of it. We understand that it's positive. So we have a negative integer times a positive. So we know that when the signs are different and we are multiplying, the answer is going to be a negative. Negative times a positive is equal to a negative. Now we can just take our 2 and our 7 and multiply it together. We already have the sign of the answer, so we don't need to worry anymore about the signs in front of the 2 and the 7. Our sign in our answer is going to be negative. So now we're just going to take 2 and multiply it by 7. 2 times 7 is 14. Next, this 6 has an invisible plus sign in front of it, or positive sign in front of it. We're multiplying it by a negative. So positive times a negative is going to give us a negative value. 6 times 5 is 30. Next, we have two negatives being multiplied by each other. So that's going to equal a positive. And then 3 times 3 is 9. But we don't actually have to write that positive. We understand that if we just wrote 9, we understand that it's positive. So instead of writing positive 9, I'm going to simplify it to just 9. One thing that we need to remember is that fractions represent division. When we see a fraction, we're actually taking the numerator and dividing it by its denominator, 12 divided by 2. So it's written in fraction form here for you, as well as using the division sign. So 12 over 2 is the same thing as 12 divided by 2, which is equal to 6. Okay, remembering that fractions equal division, I'm going to rewrite my fraction here as division. And we're dividing here, 2 negatives will equal a positive. 6 divided by 3 is 2. Next, we have 6 times 9 divided by 3. So remember, this means multiplication. When you have a number beside a bracket, we understand that that's multiplication. 6 times whatever is in the bracket. And it's rewritten here for us as well. 6 times 9 divided by negative 3. I'm going to follow my BEDMAS here, and I'm going to simplify my brackets first. 6 times, so 9 divided by negative 3. So 9 is positive, 3 is negative. So my answer is going to be negative. 9 divided by 3 is 3. 6 times negative 3, 6 is positive, 3 is negative. My answer is going to be negative. 6 times 3 is 18. And finally, negative 16 over negative 4 times negative 2. So this is the same thing as saying negative 16 divided by negative 4 times negative 2. So I'm going to simplify my brackets first. So negative divided by negative, that's going to equal to a positive. 16 divided by 4 is 4 times negative 2. And then a positive times a negative will equal a negative. 4 times 2 is 8. There is an integers review worksheet available for you to complete, and there's going to be an answer key as well attached. So please double check your answers to ensure that you received all the correct answers. If you have any questions, please join the Zoom or you may message me. Great job today.